Hi everyone, this is Sar from Boldport. I'm going to talk about the new project that is coming to members, or going out to members next week. It's called PIPS. PIPS is the dots on a die, and the project is a digital die. Let's see what right, a digital die, which means that well, we'll go through the operation of the thing in a minute. All right, this is what it comes out. Comes in this little pouch that kind of was inspired by what might D&D experts carry their die in, and their dice. So decided to use die as a singular for dice, although dice can apply to both singular and plural, according to the internet. So that's the tag. There's a little thing in the back. You can get a better glimpse of it when you get it. The URL on it is not active yet. It will be in a day or two. So what you get inside are the components, of course. A analog die and a beautiful matte black PCB that is out of focus. We'll sort this out, this focus thing. Yeah, there we are. Nice, isn't it? So I'm not going to do an assembly of the project now, but I'm going to discuss a little bit about how it works and some of the prototyping details, and show you the final thing. So the prototype, we got a few of those. And one of the main things, or things that I wanted to test with this, was taking these 9-volt battery contacts and putting them sort of as surface mount. It's not quite surface mount because they go through the two layers, but these are relatively cheap. The other options seem to be quite complicated and more expensive. So I thought, well, how do you do that? So I came up with this, which is which are these exposed pads with some reliefs, so you can you can solder the contact to the PCB. And the way you do that is by placing the contact like that and soldering it in place in a couple locations, like I do here. Don't need to use a lot of solder, and these little pads are also quite optional because it's pretty solid. And then the battery goes on like this. The contacts, you could put the contacts here like I did with this one, and connect the battery like from the front. But it really depends on how you want to do it. So before we go to the operation of the thing, I want to show you the infographic that I just finished preparing, and you can see the circuit and the assembly information and quite a bit of detail on how to put the battery contacts together. Now, I should mention that this project, I knew I wanted to do a digital die. Sorry, keep looking at the monitor. I have to get used to this. I wanted to do a digital die circuit, and I've spent a couple of days looking at the different options that I have and designing my own. And then I found this project from Elector that implemented this digital die concept very elegantly, and I really couldn't improve on it. So I contacted Elector, and they gave me permission to use it as the basis of this project, and that's very kind of them, and I really appreciate the support. We've done previous projects with them, the TAP, MOSTAP, and so on. So the project, the way it works is this is running, and actually now that I'm looking at it through the camera, you can see it because of the frame rate. You can see it kind of flickering, but when you look at it with the naked eye, you don't see it flickering. And when you press the button, it stops on a particular state, one of 6 states of the digital of a die, a D6 die. 3, I think 5, yeah, so we've seen them all. So let's go quickly through the circuit. Now, what's interesting, these LEDs, these are Cree LEDs, and they're incredibly efficient. This is at less than half a milliamp per LED. It's quite remarkable. It's a 9-volt in series with a 15K resistor, and there's 2 LEDs in most cases, in all cases, except per line, except for the middle one, that there is just 1 LED. So I printed out. I just want to go through some aspects of this circuit. So at the base of it, there is the CD4060B, which is a ripple counter, a 14-bit ripple counter that has a built-in oscillator, and these essentially 3 components determine the frequency. And in the page of the project page, I go through some of the how to calculate that. At the moment, it's running between 7 and 8K, depending on the value of the resistors and the capacitor and their tolerance. So it ranges depending on, because these would be plus 5% and this would be plus 5%. So there's some variation there, but for this purpose, we only need to have something that is running fast enough so we don't see with the naked eye the different states. And the button is a single pole, single throw, normally open button. So that's why it's running while the button is it's not pressed, and when you press it, it shorts this input to ground, and the chip stops counting, and that's when it stops. So button, ground, and stops, and when you release it, it's going through all the states very fast at say 8 kilohertz. So that's this bit. Here I put 2 resistors in parallel, the same value, because RS needs to be bigger than 2 are X, and smaller than 10 are X. So that satisfies that, and then I don't have to supply a different value of resistor with the kit. So the states, I'm going to go through just one state, and we could do, you could do an exercise of for the rest. So we'll do 0, 0, 0, which is the reset state. So this is the most significant bit, least significant bit. So B5, B4, B3. And so this is 0. So that means that this PNP transistor is on. So the voltage from the 9-volt battery, or current, will flow through here to here. And the reason it's flowing, you'll see in other states, is because this is also 0. So it's 9 volts, 0, there's this current going through. If it was 1, 0, 0, there won't be any current going through this. So this LED is on. Now 0 here to supply this branch. Of course these would be off. These LEDs would be off because it's 0 here and 0 here. And now we have these connected, this branch and this branch actually connected to the same control, which is 0 again. So we have this, and so that is 5. The table is here. One of the clever things of the engineers who came up with the circuit is that they made the observation that you don't have to go, you don't have to match the counter output of the chip to the digit that it's showing. So 0, 1, 1, 2, 2, 3. Instead, it's done more efficiently by having this sequence 5, 3, 6, 1, 2, 4. And of course it doesn't matter, right, because it's giving us this random output anyway. It just needs to scroll through these with at equal time. And the other interesting bit here is the reset, where now it's scrolling through 0, the state 0, 1, 2, 3, 4, 5. That's 6 states. And then on state 6, the binary 6, it needs to reset because it needs to go back to 0. And the observation is that you have the states going 0, 1, 2, 3, 4, 5, and the 6th state is 1, 1, 0. The only state that has 1 and 1 as the first, the most significant bit, and the bit after that. So they use that here to but to have this high. So the reset, which is active high, resets the chip. So otherwise, it's a wired AND. It's called a wired AND. So where in every other state, one of these is 0. So if it's 0, the reset is not active, and once it's sort of released, it goes to, not released, but when this is 1 and 1, it resets and immediately goes to state 0, 0, 0. So it's I suppose there's a very short amount of time where it's transitioning between the states of state 6, which is 110, and the state of all zeros, which is give us 5. So it's between 2, the digit 2 and 5. So a very elegant single chip circuit. That's what I liked about it. It's because this counter has the oscillator in there. You don't need a clock source, so you have a single chip. There are other circuits and ideas out there that have more that have a 555 and some other arrangements to get that thing. So that's the circuit. The infographic is already on the GitHub repository. It will be linked from the page, and yeah, you'll be able to see it in more detail. One other thing, this is project 7, Touchy, and it's a capacitive touch project, and we did it with your circuits. And when this got back, I saw that they changed a little bit between black, what we call black, and matte black. So this PIPS board are matte black, which is, I think, much nicer. Well, it has a certain appeal to it, and so it's a bit different. You can also, if you wanted to, like I did with this one, you can put the LEDs on the other side. You don't have to have it on the front or on the component side. But then, okay, you have a couple of seconds to guess what would happen. You would have the diagonal pips the other way around from what you would expect to be a standard direction. So this 3 is like that, whereas normally you would expect it to be like that. And another thing that you could see here is that you could put the push button, in flush with the board or against the edge, and that makes it easier to press. Finally, with the button, oh yeah, this is somewhat not important, but interesting. I said that this is normally open. There are push buttons that are normally closed, which means that they will only roll when you're pressing them, and they'll stop when you don't. But those are much harder to get by, and they're more expensive. So we've added I found one, and I specified it in the infographic and the website, that you could place it here. The pads are a bit extended here, so you can place it if you wanted to, but you'll have to get it on your own because it's not included in the kit. That's it. So we're shipping next Tuesday. And in other news, we have the discount code, the £10 discount code, because we reached 500 members. You can find it on the blog. So if you go to boldport.com/blog, you'll find this latest article. There is a discount code for £10, but you have to be a member to use it, and you can buy anything on the shop using that discount code. And that is only valid until the 10th of this month. So if you haven't used it, use it and buy some extra kits. What else? There was a little note I left here. Discount code, yeah. Oh yeah, we got a new scope. This nice Tektronix TBS series. I'll change this here. Yeah, that's better. Yeah, it's very nice. It is nice. So I'm hoping to hook it up and in later videos be able to do some more of that, some more with the scope. And yeah, lots going on, building future projects, which we'll talk about some other time. That's it. Hope you like this one, and see you next time.